Let's learn about influencing Ospf metrics. In the previous lesson, we learned that Ospf assigns a cost to each interface, which make it possible for SPF to calculate the best routes. For example, the interface E21 has the cost of 10, the interface F10 has the cost of 1, the interface S22 has a cost of 64 and the interface F00 has a cost of 10. In this lesson, we will work with the formula that Ospf uses to calculate the cost for an interface. From there, we will manipulate the cost by changing the components in the formula. Here is the formula to calculate the cost that Ospf assigns to an interface. From the formula, Ospf interface cost equal to the reference bandwidth divided by the interface bandwidth. The default reference bandwidth equal to 100 megabit per second or 100,000 kilobit per second. This table shows us the cost for each interface type with its default bandwidth setting. As you can see, we can easily manipulate the default cost by changing the interface bandwidth, set the cost, or changing the reference bandwidth. In the previous lesson, we also learned that Ospf only keeps the best routes, which are the routes with the lowest cost, to a destination. So what happens to the routes with the same cost to the same destination? The answer is that Ospf will use both routes and perform equal cost load balancing. For example, the interface F00 and F01 on IT Life Skills Router 2 have the same cost of 10. Therefore, Ospf will load balance between the two links for any traffic destined to the destination subnet 10.0.30.0/24. Here are the two commands that we use to verify Ospf load balancing. Let's issue the first command, then hit enter. The command shows us the content of Ospf RIP table, and we see that any traffic destined to the destination subnet 10.0.30.0/24 will be load balanced among the two routes via the interface Fast Ethernet 00 and Fast Ethernet 01. Now let's verify the routing table by using the command show IP route, then hit enter. From the routing table, we see that the two routes are installed into the routing table as equal cost load balancing with Ospf. Before changing the interface bandwidth, let's talk about some of the impacts that we may run into. By default, the interface bandwidth is set the same as the transmission speed, but changing the interface bandwidth setting does not influence the actual transmission speed. However, several iOS features utilize the bandwidth setting. It is advisable to avoid changing the interface bandwidth to influence the default Ospf cost. Now, let's talk about the change that we will make. As you may remember, on IT Life Skills Router 3, the cost of the Fast Ethernet interface F10 is 1. Now let's change the bandwidth if the Ethernet interface is E23 to 100,000 kilobit per second, so that it has the same cost of 1 as the interface F10. After changing, we must be able to see Ospf on IT Life Skills Router 3 load balance the traffic via the interface ES23 and F10 to the subnet 10.0.0.8/30 and 10.0.20.0/24. Here are the two commands that we use to change bandwidth setting. As you can see, we are at the configuration mode of IT Life Skills Router 3. Let's go to the interface E23, then hit enter, then issue the bandwidth command and X out this and verify the RIP table by using the command show IP OSPF RIP. As you can see, any traffic destined to the destination subnet 10.0.0.8/30 and 10.0.20.0/24 will be load balanced between the two links via the interface F10 and E23. Now let's verify the routing table by using the command show IP route, then hit enter. From the routing table, we see that only one route installed into the routing table via the interface F10. As you may know, in Ospf, there is a feature called maximum path to limit how many links can be used for load balancing. The reason Ospf on IT Life Skills Router 3 did not install the second route into the routing table because it may be configured with maximum path. Let's verify it. Here are the commands to change maximum path on an Ospf router. First of all, let's verify the Ospf configuration by using the command show run and filter for the section router, then hit enter. As you can see, currently the maximum path is set to 1 on IT Life Skills Router 3. To allow load balance on two links, let's go to the configuration mode and issue the command router ospf 1, then hit enter, then issue the command maximum path and put it as 2. Then X out of this and verify the routing table show IP route. As you can see from the routing table, any traffic destined to the destination subnet 10.0.0.8/30 and 10.0.20.0/24 will be load balanced between the two routes via the interface F10 and E23. Now we want to load balance the traffic from IT Life Skills Router 2 to the destination subnet 10.0.10.0/24. We will load balance the traffics using the two routes. Here is the first route and here is the second route. And we know the current cost on each outgoing interface along the two routes like this. To satisfy the requirements, we need to set the costs on the interface F01 to 9 like this. Here are the two commands that we use to set the interface cost. As you can see, we are at the configuration mode of IT Life Skills Router 2. Let's go to the interface F01, then hit enter. Now issue the command IP OSPF cost and set it to 9. Now let's act out this and verify the OSPF RIP table. Show IP OSPF RIP, then hit enter. As you can see, any traffic destined to the destination subnet 10.0.10.0/24 will be load balanced between the two routes via the interface F01 and F00. Now let's verify the routing table by using the command show IP route, then hit enter. As you can see from the routing table, the two routes destined to the destination subnet 10.0.10.0/24 are installed into the routing table correctly. Let's assume that we want to upgrade server links in the network to 1 gigabit per second, and we may upgrade to 10 gigabit per second in the future. However, from this table, we see the links with the speed of 100 megabit per second or faster have the same cost of 1, which means SPF treats these links the same. And from this formula, to allow Ospf to differentiate the links faster than 100 megabits per second, we must change the reference bandwidth to a faster speed than the fastest interface bandwidth in the network to allow the room for higher speed in the future. And to ensure the cost calculated consistently, we must change the reference bandwidth on all the routers. In this case, we need to change the reference bandwidth to 10 gigabit per second on all the routers for future growth. Here are the commands to change the reference bandwidth on IT Life Skills Router 4 to 10 gigabit per second, which means the 10 gigabit per second links on router 4 has the cost of 1. Please note that this number measures in megabit per second. First of all, let's verify the current cost on the interface F00 on IT Life Skills Router 4 by using the command show IP OSPF interface F00, then hit enter. As you can see, it has the default cost of 10, which means its bandwidth is 10 megabit per second. Now let's change the reference bandwidth on IT Life Skills Router 4 by first going to the configuration mode, then issue the command router OSPF1, then hit enter, then issue the auto cost reference bandwidth 10,000 to make it 10 gigabit per second, then hit enter. As you can see, it says that to ensure the costs calculated consistently, we must change the reference bandwidth on all the routers. Now let's verify the current costs on the interface F00 again by first X out of this and issue the command show IP OSPF interface F00, then hit enter. As you can see, after changing the reference bandwidth to 10 gigabit per second, the interface F00 has a default cost of 1,000.